Welcome to another edition of Math That Matters. It's going to be great. We're starting some new stuff today. It's similar to the logic unit, but we are talking about statistics now, statistics and critical thinking. So instead of just thinking about all the possibilities and what is true and what is false, we're looking out and we're observing and we're taking in information and we're creating empirical arguments. These are inductive arguments whereby we'll come to conclusions, but what we will say is there probably is this reality, and we won't necessarily know for sure, but the probability has some sort of certainty attached with it, or I guess uncertainty. And this is a different way of thinking, but very, very useful and I think interesting. So let me take you into my PowerPoint. The first thing that I want to bring up is there will be an exam coming up soon. And in that exam, I'm going to give you one of my all-time favorite Bible verses. If you memorize this verse, you'll get a whole lot more than the one bonus point I'm going to give you on the test. But I'll give you a bonus point on the test. And yet, if you memorize this verse and internalize it and believe it and hold tight to it, it may just change your life. So here it is. Jude 1, 24 and 25. To the one who is able to keep you from stumbling. I think that is kind of hard to do because I stumble and probably you stumble, but there is one who can keep us from stumbling. To this one who can keep me from stumbling and to present me and you before his glorious presence without fault. I love that I get to pray to the one who presents me before glory without fault, even though I have fault. I have much fault, and with great joy. I love that when I picture Jesus and how he looks at me and how he presents me, he doesn't do so with shame. He does so with joy. He doesn't do so with reservation. He does so with full assurance, with complete validation. To the only God and Savior be glory, majesty, power, and authority through Jesus Christ our Lord, before all time, now, and forevermore. So be it. It doesn't get any better than that. Memorize that verse. Put it down on your next test, and it's something to live by. All right, here we go. Well, this is a contrast, isn't it? Statistics and critical thinking. This would be CT-1. It's mostly about bad samples, bad explanations, and bad analogies. In other words, there are ways to make these arguments, looking out at the world and collecting data, there are ways to make these arguments badly. And that's what can be so frustrating about statistics. In fact, Mark Twain is famous for saying this, though I don't think he was the first. There are lies, damn lies, and statistics. I actually have this book right here, and I'm going to read something to you from it, which illustrates the point. It says, consider the early estimates for the crime of stalking, S-T-A-L-K-I-N-G. Concern about stalking spread very rapidly in the early 1990s. The media publicized the problem, and most state legislatures passed anti-stalking laws. At that time, no official agencies were keeping track of stalking cases, and so no studies of the extent of stalking had been done, and there was no way anyone could know how often stalking occurred. After a newspaper magazine story reported, quote, researchers suggest that up to 200,000 people exhibit a stalker's traits. Other news reports picked up on the suggested figure and confidently repeated that there were 200,000 people being stalked. Soon the media began to improve the statistic. The host of a television show declared, there are an estimated 200,000 stalkers in the United States, and those are the only the ones that we have track of. An article in Cosmopolitan warned, some 200,000 people in the US pursue the famous. No one knows how many people stalk the rest of us, but the figure is probably higher. Thus, the original guess became a foundation for other, even bigger guesses. So you can see what happens. All you have to do is fudge a little bit, and the next person fudges a little bit, and the next person fudges a little bit. Pretty soon you're so far away from what was originally said, it doesn't make any connection to reality at all. So how can we not just hate statistics, but how can we ask them to speak to us truthfully? How can we find the truth, accuracy, what is? How can we look into the world and see reality with all of the, I guess, competing lies and positions that may have some sort of other agenda at play? Well, there are some things we can do. Empirical or quantitative reasoning, looking at the numbers and trying to figure out what they're saying. We try to make statistical generalizations. So we look around and we say, what's happening, maybe not all the time, but what's happening most of the time. And the problem is that we don't really know what's happening all of the time because we're not there all of the time. Pretty much the things that we want to know, almost to some degree, can't be fully known, at least by our methods, using the amount of time we have, using the amount of money that we have. There's just limitations to being all-knowing, and so we have to look at something in part and try to make some sort of a claim. So if I say 67.5% of all prisoners released from prison are rearrested within three years, that's a generalization. It's not a rock solid, firm for sure, but it is a partial generalization with a numerical value associated that probably comes from some data. It is much more precise than saying most prisoners released are rearrested within 3 years, but it's not so strong as saying all prisoners released are rearrested within 3 years. So we're going to start attaching probabilities. And a lot of times we just look out at the world and we see the percentages that are available to us, and then we project into the future and say, if things remain the same, then the likelihood of them happening is, and then we forward the number that we observed, which isn't necessarily irresponsible, but it does make an assumption that things will remain the way that they are. And it also makes the assumption that we have accurately understood the way that they are. So you have to be real careful with kind of the strength of the assertion that you're making in these types of arguments. Here's an inductive argument. 70% of voters say they will vote for candidate X. Therefore, this is my conclusion, candidate X will probably win the election. I mean, that seems pretty reasonable. If the premise is true, the conclusion is probably true, but it could be false, right? There could be 70% of the voters say they will vote for candidate X, and then they don't vote, or then candidate X dies or something like that. So it doesn't mean that candidate X will win, but there is some evidence pointing in that direction. So we use the word probably. We also, of course, need to make sure that in the argument, which isn't making a complete claim, not 100% claim, but we also have to have a true premise. So the numbers that we have from the statistics, if they're not fairly representative, then the argument falls apart. Of course, we can probably remember the 2016 presidential election when the polls were so dramatically wrong. And I think that's I guess the polls weren't very right in this last election, but they were so wrong in the 2016 election. And a lot of the pollsters lost credibility over that because they said one thing before the election and it was a complete misrepresentation because something totally different happened, which wasn't normal until then. So what do we want to do? We want to, and you probably saw this in this week's video, we want to learn to speak to the numbers and ask them to come forth. We want to find reality as represented by numbers that are there but unseen. And so how can we coax them out of hiding to speak to us in ways that point us toward the truth? And you probably don't remember the movie The Horse Whisperer, but he spoke to this wild stallion and he was the only one that could tame this wild stallion, and it was kind of awesome. But I talked about that in the other video, so we'll keep going. Here's the key. The key to number whispering is there's something happening out there in some population, and the reality is we can't measure everyone or everything in that population, and so we take a sample. Now, if we just walked in and we just grabbed these 4, that sample of 4 is probably not a very fair sample, because if I'm grabbing from this edge, these people over here didn't really get a chance to be picked. And you can see how many people are in the population. And the question is 4 enough? So was it fair that these 4 got picked? And was 4 enough out of who I have here to have this sample fairly represent the population? And those are the 2 things that we want to examine. These are the 2 pillars of number whispering. And that really is the sample size sufficient? And did I get an unbiased sample? Did I fairly pick? And to fairly pick, really what you have to have is you have to have equal probabilities of selection. That means everybody in this population needs to have an equal chance of being picked. And that way, my sample is going to fairly represent if it's large enough. But there are all sorts of ways to do that badly. But again, these are the 2 pillars of sampling. If we want to be good number whisperers, we have to have an adequate sample size. The size has to be large enough to support the generalization. And I will say too, with that, whenever you sample, you always want to describe the population that you're drawing from, because a lot of times you miss people in a population that you're supposed to be representing. For example, the Gallup Poll. Gallup is an organization in the United States that does a lot of statistics and analyses, but they do a lot of phone polling. And so if you don't have a phone, if you can't be reached, then that part of the population is not being represented. Or maybe you're in jail or something, you don't have a phone, or you're out of the country and can't be reached. So you have to be careful to say these are all just people that have phones, or whatever way, whatever part of the population you haven't represented, you probably should exclude them from your statement about what population you're representing. The other key is to have a non-biased sample. That is that everyone or everything that is being sampled from the population has to have an equal chance of being sampled. Otherwise, you have bias. And I will put this on the exam. I'll say, what's the key to a non-biased sample? And you'll say equal probability of selection. You can't simply say randomness, and some textbooks do, but that's not enough, because if I have randomness with phone calls, for example, then I'm leaving out the people that don't have phones. I'm definitely not, well, I was going to say not representing the kids, but who am I kidding? Kids have phones now. That's terrible. But that's another veer of thought. So how can we do this rightly and well? And how can we do this wrongly? How can we break the rules or commit a fallacy? And what's a better way? So hasty generalization is when we break this rule of having an insufficient sample size. So we're generalizing, but we don't have enough information to really fairly generalize. So we went to Florida in January. We were looking for some alligators, and we thought for sure we would see some, and we didn't see any. And that was really pretty disappointing. We actually only went out and looked one day. We went out to the swamp and we looked one day. So my sample size was one day. And so we could say, there's no alligators in Florida based on my sample of one day, and seeing none, there's none. Of course, that doesn't make any sense. That's an error in thinking, because my sample size is not large enough. I did have a BMW, one of the worst financial decisions I ever made. Lost a lot of money on it because every time I took it in for something small, it was like $800 to fix. So my BMW had lots of expensive necessary repairs. That means all BMWs need lots of expensive repairs. My sample size is 1, although my friend, Kent, who told me not to buy it, said that BMW actually stands for big money waste. And so I think he was probably right. I think other people have had the same experience. Cool car, but a lot of problems. All right, how else can we break the rules? Sample bias, directional sampling methods and or procedures. So here's a similar one to what I illustrated hasty generalization with, but this is a different reasoning. So we saw no gators in Florida, so they must not live there anymore. So sure, it was a sample size of one day, but also we only looked in January. So not all the months were fairly represented, and we actually heard that they're stuck in the mud hibernating when it's that cold. Didn't seem too cold. It was about 68 on average. But you can see if my sampling method leaves things out like all the other months than January, then that's not a fair sampling method to represent if gators are in Florida or not. Here's another sampling method. If I say, I wonder what people feel about gun laws, and I go out to Field and Stream subscribers, and I don't define that I'm drawing my sample from that population, and I'm probably going to get a whole lot different opinions on gun laws from that group of people. But it's amazing how often a sample will be done, real statistics will be collected and calculated, and what they don't do is they don't give you the population that has been drawn from. And if you just pick a population that will kind of represent what you want to say, then you're going to be able to say what you want to say. And if you exclude that population's definition from your statement, then you typically include a whole bunch of people that weren't fairly represented. So that's sampling bias. Here are a whole bunch of different sampling methods. There are more. And the ones in green are the good ones, the probability sampling methods. The most obvious and useful one is a simple random sample. And essentially what you do is you get a list of every individual or item in that population. You assign a number to every individual, and then you get a random number generator, and you randomly pick the sample of whatever size you decide. So that's called a simple random sample, and that works really good. In fact, if you get a really good simple random sample and you've got a list of everyone, you're not leaving anyone out, that can be a pretty good way of surprisingly representing large populations with relatively small samples. I mean, I think there's 350 plus million people in the United States, and that can be fairly represented with a sample of about 1,100 as long as you have randomness and equal probability of selection. So that's surprising. But it can be statistically validated that that sample is of a good size. Cluster sampling just means that you're going out, like if I said, I'm going to take this city, separate it into blocks, and then I will randomly pick blocks, but when I go to the block that is randomly picked, I'm going to sample everybody on that block. There's some other ways to be fair about things. Systematic sampling, we could pick like every fourth person or every fifth person or something like that. Stratified random sampling means we split into strata or different categories, and maybe we even sample proportionally out of those categories, like freshman, sophomore, junior, senior, and we want like some evenness or some percentage fair representations from those categories, then that can be fair too. Some of the bad ones, these are non-probability sampling methods, which means there are odds in directional favor. So convenience sampling is you just do whatever's easiest. You just walk outside and you take your sample, and you happen to get represented whatever's represented near you or most easily. There's judgment sampling or purpose sampling, which means you kind of like look at a bin of apples or something and you say, I wonder what the average apple quality is or something like that. And so you pick some that look kind of bad and some that look kind of good and some that look kind of in the middle. And if you're the judge, obviously your statistics show what you thought you saw. That's not fair. Snowball is just kind of like going to a group and just sampling. So that's kind of more of a convenient sampling. Quota sampling would be forcing yourself into sampling a certain number from a certain category, rather than stratified is sampling randomly within categories. So quota is like forcing a certain number from a category in. And there's lots and lots of other biased sampling methods. Polling can be real bad. Talked about that a little bit. Voluntary response. If it's a survey and there's a voluntary or incentivized response, you say, I'm going to give you $5 if you fill out this survey. Well, someone who needs $5 more might be more apt to respond, or somebody who really cares about the thing you're asking about will respond, whereas somebody else that doesn't care won't respond. So you unfairly represent the people because you're only getting the people that are interested. A lot of other things, lack of blinding or double blinding. If you're running an experiment, there's a placebo effect. And so we usually have what's called a control group. And that means there's a treatment, maybe we're testing a drug. And so that drug is being given to some individuals, but it looks like that drug is being given to other individuals in what's called a control group but they're not really being given the drug. They're given like a sugar pill or something that has no effect. But they don't know that. They don't know that they're not getting the drug, because the placebo effect is something that kind of is verified that we are mental, and that when we think something is happening, we can even respond to that physically. Double blinding just means that the researchers that are observing also don't know if you're the one getting the placebo or not. Oh, this stuff is really interesting and widely used, even though it's problematic. The extrapolation. So you're like, well, there are some people or some groups, some parts of the population that we didn't get to, that we couldn't get to, but they're probably going to respond like this. And so you project into a population that is missed with a mathematical model. So anytime you see mathematical models, be wary of that, especially if they're extrapolating. They're going beyond the observations and into some assumptions. So sometimes you have to do that, but it's really pretty dangerous. Yeah, survey sampling, talked about that a little bit. Biased questions, word choice. You know, this is from the text, the logic text. We're in chapter 3 now, by the way. You get this question on survey. Which do you prefer? Products that are expensive and have no FDA proven advantage over the less expensive products, or products that are inexpensive and have no FDA proven disadvantage over more expensive products? You know, maybe this is a poll trying to figure out people's choice or preference as it relates to organic food. And you can see that I put this in red and this in blue. This is a little bit maybe hostile or objectionable, or I don't really like it that way. And this is a lot more endearing. I mean, I'd rather have inexpensive, especially if the other thing provides me no advantage. So you can see that the wording of questions can direct the person taking the survey toward or away from a particular response. So you have to be really careful with that. All right, so how to cheat. And I guess how to cheat, I'm not trying to teach you how to cheat. I'm trying to teach you how to not cheat, actually, and how to observe cheaters, right? Ones that are not using good practices. And again, these are the two pillars of sampling. We want to make sure that the sample size is large enough, and we want to make sure that the sample is not biased, that it's been fairly polled. And again, equal probability of selection is the key for a non-biased sample, and this will be on the exam. Equal probability of selection. So make sure you write that down and remember it. The other one that I'll illustrate now is adequate sample size. If the sample size is not big enough, it's not fair to make a generalization from that. In fact, if your sample size is too small and you make a generalization, it's called a hasty generalization. Right, my friend's been eating hamburgers, pizza, and fries for 10 years. He's got no health issues. So I think fast food is actually pretty healthy, or at least it's not unhealthy, right? But if you think about it, that's a sample size of 1. And we probably all know people who have had poor diets like that, or maybe smoked for years or whatever, and it seems like they get away with it as far as their health goes. But that is a small sample size. If you took a larger sample of people that had bad eating habits, I think you would find a significant difference between their health and the health of others. So I want to make sure that we have a fair sample size. And I think this is a really good illustration of the point. Stories versus statistics. Remember, a story is a sample size of 1, but stories can impact us so significantly. Joseph Stalin, who was not a good guy, right? Joseph Stalin actually killed millions of his own people as a leader. He said 1 death is a tragedy. You know, we don't want a tragedy, but 1 million deaths, that's just a number, right? And if you think about it, whenever we hear a story, it just sells, you know, it sells us. It endears us to the characters. It humanizes a statistic, even if the sample size is 1. And I'm here to give you at least an example of how a story can be an irresponsible argument. So I was watching a movie fairly recently, and I thought it was actually a pretty good movie. It was powerful. It was based on a true story. It was called Just Mercy. And in this story, an innocent man gets wrongly convicted of a murder, and he's sentenced to death. And so we're just like, we're getting to know this character in the story. We're falling kind of in love with his character. He seems like a good guy. He probably is a good guy. but yet he is supposed to go to the electric chair. And we're just like, this is horrible. This can't be. In red, right? This is alarming. What can we do? And the movie's cool because there's this set of circumstances that are amazing and courageous, and people make sacrifices. People take risks to get the truth to be coming out. And in the end, the man is set free. Hope is fulfilled. Joy is restored. Everybody just like, you know, we're just dancing. We're so excited that justice is served. And the story is great. And then, of course, there's some statistics at the end of the movie that are kind of like, hey, this is a big deal. Like, people that don't commit crimes shouldn't be punished, especially with the death penalty. And we all agree. Everyone can agree on that, right? So I'm not even saying it's a bad movie. But we kind of get wooed into this, the significance and the power of the one story, the sample size of one. And I'm not saying there's only been one person that has been in that category. Ben Franklin is famous for saying this: it is better that 100 guilty persons should escape than one innocent person should suffer. And I think that sometimes we hear a quote that's so often repeated that we kind of make it gospel truth. And then it just becomes this principle. And I don't know that I'm in agreement or disagreement with that quote, but it seems like it comes from somewhere powerful. It's our American history, I guess. And we got this story and we got this quote. And I just want to remind you that every statistic has a story behind it. Like, every one of the millions that Stalin killed had a story. We just don't hear the stories. And that's what Stalin kept people from, was the humanization of every single person that he murdered. And I just want you to remember too that justice goes both ways. If an innocent person being condemned goes against our moral fiber, what about when the guilty are set free? Isn't that a problem too? In fact, the statistics show the vast majority of criminals actually did commit the crime that they are punished for. And far more often than the innocent being punished, the guilty go free, even when they're indisputably guilty. Everybody might remember the O.J. Simpson trial where he murdered his ex-wife back in 1994, and he got off on some technicality, right? But we all knew he did it. There was plenty of evidence. So a guilty person went free. And part of that reason is that you are presumed innocent until proven guilty beyond the shadow of a reasonable doubt. That's the way that the court system is set up. I remember I was on jury duty once, and they were selecting jurors, and they got to me and they said, the guy says, is my client innocent or guilty? And I said, innocent, right? Because there had been no case. So you start with an innocent status, and then the evidence is brought, the case is brought forward. Also, I think it's worth saying that statistically speaking, very often the guilty who are let off the hook commit more and even worse crimes. So we can verify this statistically. Like the people that are guilty that don't get punished go out and it's kind of like, oh, I guess I can do it again. Or maybe that they aren't rehabilitated. Maybe they're not repentant. And this is a pattern of behavior they're going to go back to again. And then even more innocent people are being harmed, right? Because they're committing crimes presumably against innocent people. Not all of them, no. But statistically, we could go out and look at the empirical evidence and say, boy, this could be a problem. And additionally, if you think about it, if we don't have just consequences for actions, we actually encourage others to participate in criminal activity, which is statistically, philosophically, and anecdotally verifiable. And we saw that. We saw that significantly last year with the lawlessness. Now, does that mean that the story isn't important? Of course not. And especially biblically, we read the story about Jesus leaving the 99 for the one sheep, right? And it doesn't mean the 99 aren't important, but it does mean that one person's story is more important, especially when the one is a person, right? The stories do matter. So I'm not saying the stories don't matter. I'm not saying that was a bad movie. I thought it was a really good movie. And we don't want to dismiss the reality and the importance and the validity of the stories because they are speaking. But we can't justifiably create a rule of logic or practice that defies what the statistics are demonstrating about the majority, what's happening most often, because every single person in that majority that the statistics are pointing towards sometimes has their own story, and we don't want to ignore that. All right, so that was section 3.1, which was probably of these 3 sections that are in this assignment. He just does these little short sections, but that's probably the most important to me of the 3 sections we're going to talk about. 3.2, I'm only going to have 1 slide on, or 2 slides, and I think he explains this really well in 3.2. Our author is a good writer. I think he speaks at a level of understanding for, I guess, normal people, not brilliant people. I'm not brilliant, I'm normal. But he gives the 7 explanatory virtues in section 3.2. And essentially what this is what an argument must have, what an explanation that tells us why something happened must have. And he illustrates all of these really well. But I'll just give you the definitions real quick here. So the 7 virtues: explanatoriness. So we have to take, if we're going to explain something, we have to take all of the facts that we can gather, and our story, our explanation of why, has to include all the observed facts. If we take facts and leave them out, which the media does all the time, then we kind of get a different explanation. We come to different conclusions. So even if there are facts that don't support the narrative that we would like to see, we want to make sure that we bring them in anyway. And that's okay, because our goal is to figure out the truth, to understand with accuracy what is, even if it pushes back against what we kind of would prefer. So our preference is set aside for the truth. The truth is what sets free. Depth. Explanations should not raise more questions than they answer. We want to explain. We want to bring better understanding, not create confusion. Power. Explanation should apply in a range of similar contexts, not just the current situation in which the explanation is being offered. So if we're proposing some rule that explains the details, then it should explain the details in a multitude of situations that are similar. Falsifiability, I think that's pretty interesting. He talks about explanations should be falsifiable. And what he'd say is something like, my socks keep disappearing. I wonder why my socks keep disappearing. I need an explanation why my socks keep disappearing. It's the sock gnome. That's my explanation. There's a gnome every night that gets into my sock drawer and takes my socks. So no one can really argue against that because it's not falsifiable. So falsifiability means if I have an explanation and no one can even push back against it, it really doesn't do very much. It's not falsifiable. Modesty. We've talked a little bit in this class about not going beyond what you can say. So don't claim more than the facts would support. Simplicity. Sometimes in mathematics, we hear this as Occam's razor. And it says the simplest explanation is probably the right one. We don't want to read other details into something that might not be a factor. So start with the simplest explanation. And if that doesn't seem to be a strong explanation, then you can move to the more complex. But the general principle is that the simplest explanation is the best. And the last explanatory virtue is conservativeness. And that simply means if there are well-established beliefs or facts that we would have to give up, fundamental principles of life and wisdom and observation, things like that, if our explanation forces us to throw out common wisdom, then our explanation is going to be less feasible. So those are the 7 explanatory virtues. I just assigned a few problems from the book. And I think that if you're doubting some of these definitions, look at his examples in the book because they're really good. Finally, and this won't take too long either, but 3.3 is analogical arguments. So argument from analogy. And the author brings up fair analogies versus false analogies. So sometimes we set up this comparison. We say thing X shares similar properties to thing Y, and Y has characteristic A, which means X most likely also has that same characteristic. So here's an example, and I think examples are the easiest way to understand whether we've got a fair analogy or a false analogy. The world record holder ran 100 miles per week. And twice a week did workouts comprised of 10-mile repeats on the track in the weeks leading up to his 10,000-meter world record. Then it's like, well, I did that too. I ran 100 miles per week. I've been doing 10-mile repeats twice a week. This is not me, by the way. I ran for a while and really liked it, but it was terribly hard on my back and my body. So running is, I think, really fun, but not necessarily as healthy as you might think. It's hard on your joints, especially when you get old. But therefore, the next race I will run probably will be a world record. So we're like, okay, here's a comparison. This world record holder had a training regimen that he followed, which led to a world record. If I can follow that training regimen, does that necessarily mean that I will set a world record also? And I think the obvious thing is this is not a good analogy, because some people just have that genetic factor athletically that causes them to be able to accomplish something special and unique and greater. And even this would be pretty special to get through this training regimen. But of course, lots of people can do that. Lots of people can't, but lots of people can, and they aren't setting world records because a world record is held by one person. So that would be a false analogy. How about this? Is this strong or weak? I feel pain when someone hits me in the face with a hockey puck. Well, I think I probably would. That hasn't happened to me. We're both human beings, so you also probably will feel pain when you are hit in the face with a hockey puck. I think that's pretty fair. I think that since if it happened to me, I would feel pain. And then if it happens to you, you would feel pain. Philosophers have talked about how pain might be a different experience for different people. So our author in the book kind of talks about that a little bit and says, you know, it might be a fair analogy, but we also have a really hard time quantifying pain because it's so custom and unique to the individual. So our author says, you know, this is probably a good analogy, but there is a route of thinking where philosophers might say, you can't just talk about people having the same pain because people don't feel pain the same way. I don't know if that's true or not. I think the second argument here, you could use the same argument, but maybe a little bit more convincingly. The color I experience when I see something as green has a particular quality, which is difficult to describe, right? How do you describe the color green without comparing it to something that's green? But you and I are both human beings. So the color you experience when you see something green probably has the exact same quality. Like this book has some green in it. To me, it's green. And to you, it's probably green. This looks kind of green up here. This looks kind of red. But color is a weird thing. And maybe people don't see color the same way. Although I guess you could statistically validate that by holding a whole bunch of green things up that you see and asking other people what they see. And if they say green, then maybe people experience green pretty similarly. So I think that's probably a fair analogy, though you could use the same kind of objection, which I don't know that many people would buy down here as we used before, where you say people's experience of green is different. It's a bit of a stretch. I read this one in the newspaper this morning. I'm a big Portland Trailblazer fan. I've been watching them since I was a kid and attending their games. So they have a player on their team, Carmelo Anthony, who's obviously a very good player. He's older as far as NBA players go, but he will be a Hall of Famer, and he's really good. At this point, he's not nearly as good as he used to be. And so there was this analogy that I thought would be fun to put into this lesson. If Portland was a movie, the Blazers, the amount of scenes Carmelo is in would be alarming to the director and the producers. I'm just saying, is Carmelo one of our stars of this movie? I thought we just hired him to do a couple of scenes. which if you're a Portland Trailblazer fan and you watch very many games, what you notice is that pretty much every time he gets the ball, he shoots. And he's a good player. In fact, he's a pretty clutch player. And if you really have to have a basket, he's not a bad guy to go to. He's a good shooter, but he just has this knack for backing players down and taking short turnaround jump shots. He's pretty good at it, but that really makes the offense stagnant. The ball's not moving very much. And he becomes kind of the central focus while people stand around once he gets the ball. Now, if you need somebody to make a three-pointer at the end of the game, he really has a lot of confidence and he's pretty good at clutch plays. But in my opinion, if he could just stick to his role better, we'd actually be better off. He should hang around the three-point line and shoot three-pointers more. Anyway, I would say this is actually a pretty fair analogy because he kind of gets not just more attention because he is a star, he's a Hall of Famer, but he gets more time than he ought to as a focal point of the Blazers offense. So it seems to be a fair analogy to me. All right, here's the last thing that I want to leave you with. This is in our textbook and it's a little bit lengthy in terms of going through, but it's an analogy that's kind of tricky to navigate. And I think our author points to it as a somewhat false analogy, but I think it's a little more fair than he gives it credit for. Here it is. So Bob uses his life savings. He buys a sports car that's amazing and expensive. One day he parks it. He's walking along a set of train tracks. Bob is not the smartest guy, so he must not have gotten his car from or his money from his intelligence. But he walks, he sees a train coming in the distance, and there's a child whose legs caught in the train tracks, and he's like, oh my goodness, it's gonna hit the child. And the train will get there before he can, so he can't pull the child off the tracks. And he just, he has a decision to make. He sees a switch near him. He can throw the switch, change the direction of the train. It will take a different set of tracks. It won't hit the kid. But Bob sees that his car is parked on the other set of tracks. Like, good job, Bob. But this is definitely not a true story, right? His expensive car will be destroyed. And he's like, whoa, wait a second. That's like my life savings. I'm 70 years old. I've been spending my whole life saving up for this Corvette. And so he's like, nope, not going to do it. The train, this is morbid. The train strikes and kills the child, leaving the car unharmed. How do you feel about Bob? What about Bob? Bob's not a good guy, right? You just can't do this. I'm sorry, Bob. You got to give up the car. This is a kid. This is a person. This is real life. Car's just a thing, right? Okay, Bob's probably even going to get in trouble. Might even be a criminal offense. Okay, now here you go. We're making an analogy. How about things that you spend money on that you really don't need to spend money on, like Starbucks, right? Starbucks is probably a big money waste like a BMW, right? So you go twice a week and you get Starbucks and it's $5 each time, and it's $5 and it's $5 and it's $5. And we know there are starving children in the world, right? If you just didn't drink Starbucks, $5 and $5 and $5, and you gave that away to some organization that could save kids if they had the money, right? Right? We could save lives with more money directed toward people that need it. And you really don't need Starbucks, right? So what you can do is you can just make your own coffee, and you still get coffee, which is delicious, but it's not Starbucks. And you could save a life. You could save a child's life, but you don't, right? Just like Bob, right? Bob could have saved the child's life and he didn't. And now we feel like Bob is bad. But you could have saved a child's life without Starbucks. Is it a fair analogy? And I'm going to leave you to think about that. Because in the book, our author says, not fair, not fair, not alike at all, and he explains some reasons why it's not alike at all. But I wonder if it's more alike than we would like it to be. And I think that it's fair to wrestle with things like that. What do I have that I don't need that I could do with that money or that time or that energy, something that would make more of an eternal difference? That might be more fair analogy than we would like it to be. So I'm going to leave you with that. to think about. Here are the homework problems. They're actually pretty quick. I don't think this is going to take a long time. I don't think it's going to be terribly hard. And I think it will be interesting, and it will illustrate basically some definitions and principles about argumentation. I hope that that is useful to you, and I'll look forward to seeing you the next time.